last week we didn't have our class because I had to go on a short trip, and network was a bit of an issue there. So we are back to our implementations. Who went through some of the things that we've been talking about? I don't know if anyone did that, just to refresh your memories on some of the things we've been talking about. Anyone? Okay, it's fine. So I mentioned that we'll talk a bit more on methods again. I'll share my screen now. I mentioned that we'll talk a bit more on methods again. Then in our subsequent class, sorry, no. Then in our subsequent class, we'll start looking at classes and objects, right? Then, so who can remind me what a method is? You can go ahead because I'm not seeing anyone. Go ahead.
Right. So a method is actually used to carry out a specific function, right? So
A method is what? I didn't hear.
method is actually used to carry out a specific function.
Okay. I think when you're defining a method, you should always use the block of code term. Yeah, so that way it shows that you really understand what that method does. It's a block of code that is used to carry out a specific function, like you said. That's correct.
All right, no problem.
And how do you define a method? Okay, let me just create this guy. Package. So, oh, okay, I can use. How do you define a method?
Okay, in Java, right?
Yes. It's Java class, so.
I mean, is there a different definition for different languages?
Say again.
Method. I mean, is a method not still a method?
No, like how to define, like how to create a method. That's not like definition. Yeah, not that definition. So how to like create a method? So anyone?
Yeah. So first of all, we declare the visibility of the method, which is public. Then we make it static.
Okay.
Then we give it the method name. It's the
okay. Sorry, so visibility of the method, which is accessor. You said something else.
And also, we make it static.
You make it static, and is it a must that you make it static?
It's not compulsory, but to be able to access it, I'll access it directly in
the main method, right? Okay. So what else? Is this still on the call? Hello, Ayodele. Okay. Can someone else go? Are you guys hearing me? Let me be sure that it's not my network. Are you guys hearing me?
Yes, we can hear you.
Okay, so
yes,
so what else? What is the other things when you are defining a method? I really said accessor, right? Public static void, public static no, public private protected defaults, those ones, yeah. And then he said you can also make it static because you can't as if you're going to call it in a static method, because you can't call static methods non-statics directly in a static method, right? So what else?
All right, sorry, my network was just taking me out, and so
Yeah, I noticed.
you declare the type, right? So you just declare the type.
Declare what?
The type, like the
Data type, right?
the data type, yeah, the data type, yeah. So
Exactly.
once the then after that you give it your method name,
Okay.
then the parentheses and the parentheses and the brackets, right, to return
Then if you have any parameters,
your
you can.
parameters or parameters.
Good. That shows that you guys understand what we're talking about. So there are some concepts that we've discussed when we talked about methods in the past, and I really did not. I just talked about it. Oh, this is how you do it, but I really did not maybe make examples of it, and also I did not. Some of them I did not tell you their use cases. So today I intend to do that. So let's just do like an example kind of stuff. So on method 2, let's say for example we have an animal, right? An animal class, and in our animal class there's one thing that is generic in animals. So they all speak, or they all make noise. Let's say, for example, not speak, they all make noise, right? But they make noise in a different way. So we'll do public, for example. Let's not make it non-static. Public, then make sound or something. Make sound, right? So let's just do a simple print here. Animal makes sound, right? So then let's say for example we now have a different class. For example, we have like which animal class now? Okay, let's have a cat. A lot of developers have cats. I don't know why. Yeah. So, and this cat extends this guy. So instead of now, because okay. So when we talk about classes and objects, we would cover this guy, extends. But what we are trying to do here is this cat class is inheriting the properties in animal, right? So for us to be able to use this guy and give it our own definition, instead of just like, because the reason for extending this thing is if there are methods here that a cat can use, right? If there are methods here that a cat can use, no need of repeating yourself here, trying to make your own personal definition of it in this cat class. So it's always advised you reuse whatever thing that the parent class has. Please remind me at the end of the class. I actually wrote an article that does a bit of an explanation on this. I would go back to writing. So that does a bit of an explanation on this. So just remind me at the end of the class to share that, please. So for us to reuse this guy, we have to override it. So we can, of course, IntelliJ gives us an option of using importing it without having to write this out. But I would do that. So this guy suggests that immediately. Now, as out a cat makes, I think it's meow sound, right? That's how meow sound.
Yeah.
Right. So what we just did is we are saying give us every other, let's say if we have other this thing here, public yeah, it's, for example, this one, it's food. What can other animals do that a cat cannot do? I want to just use that as an example. Okay, let's take for example, it's house cats that we're talking about, and this animal also covers every species of animal. Let's say kills, right? Though cats can kill rats anyways, but let's just assume that.
Yeah.
Say again.
Fly.
Oh yeah, exactly. A good example. Public void fly. So we all know cats cannot fly.
Yeah.
Or bird is an animal and it flies. So what this kind of this thing gives us is it gives us an opportunity to make you reuse some of these methods that we know that is needed in cats and make our own implementation of it. Another class that can fly like a bird would just come make this other one, right? We know it also makes noise, it kills, it preys on its own this thing, but and then it also flies. So a bird can actually take all these four methods, these four performances, but a cat can only take one. So this override helps us to it provides us the what's it called specific implementation. So it gives us the opportunity to have a specific implementation of a method that already exists in a superclass, right? That's what method overriding is about. So let me just, this is called method overriding. Overriding. Okay, so it gives us, provides us access to specify our implementation of a method already in superclass. Okay, so this is what it does. So if we run this class, if we run this thing now and say, oh, animal make noise, it would make, sorry, like cat make noise, it will make the noise of a cat. If we have the other methods too, it will do all those things. But we all know that cats can't fly, so there's no need implementing it. Then when we go to bird, if we have a bird class, bird will extend animal and then have all the implementations that it have all the implementations that is here, because we know that bird has all those capacities. Is there any question?
No.
Okay. So what happens when we don't use this guy? So this guy actually helps prevent accidental errors. Like when we are calling this, when we make a call to make noise, our code will be like, okay, so which make call are you referring to? Because it exists here, and this guy also has the same thing. So saying override, when we are calling the cat this thing, it knows, okay, I am to call only this one. Okay. So, and also when we get to the 4 pillars, I don't know, some of us should know the 4 pillars of OOP, object-oriented programming. It helps, this overriding, method overriding helps us to achieve polymorphism, runtime polymorphism. Polymorphism simply means giving our code or a behavior on runtime. So once when this code is running, and this sound should be the cat sound, depending on how we are calling it. If we are calling the bird, it should give us the behavior of a bird and not give us the behavior of a cat. That's one of the things that this polymorphism helps us achieve. I don't know if it's clear. I don't know if it's clear.
Yes.
Okay. All right, so that's an example. So another thing that we also talked about is we talked about method overloading. So method overloading is simply a way we can use this, we maintain the same name for our method, but then pass different parameters and different data types in the parameters, right? So let's say we can have, for example, we can have a method like this, int that adds two numbers, right, and returns the number. But what if we want to add three numbers? We should be able to do the same add, but in this case now, we do the third one. It should take it. If we want to maybe do add decimal point numbers, so we talked about double, right? So we still maintain our add and then maintain these two guys. So return a plus. Oh, okay. I made a mistake here. It won't here. So this is, we return, it's the same name, but then we now know different functions. We're expecting different results. If I pass 2 point something plus 2 point something ish, we should expect to get maybe 4 points, whatever thing that is left. Does it make sense? Hello, does it make sense?
Yes.
Okay. So the thing is, another thing too, you should also know that your return type does not affect the overloading, right? Your return type does not affect your overloading. It's mostly your parameters that define the difference in the method. If we say something like this now, and what should we call? Okay, first off, let's do this guy. Let me comment this out.
Sorry, please, sorry to take you back. Please, my network took me off. I don't know. Please, what are we doing here?
Oh, okay. We are looking at method overloading.
Okay.
So I was saying your return type doesn't make a difference. What actually makes a difference in your method overloading is your parameters. You see, even though they have different return types, it's still telling me that it has been defined, that this name has been defined. The only thing that will make a difference now is when I maybe add one. Of course, it will throw an error. If I add one more this thing here, it's okay. It didn't throw an error because we are returning whatever thing we return, it will just convert it. Yeah, it will convert it automatically. But the idea is the three things here is what makes for method overloading and not the return type. Does it make sense?
Yeah.
Okay.
So is it a parameter that actually makes the difference?
Yeah, it can actually be more than three parameters. It can, yeah, it's the parameters that makes the difference. It's not, if we can even we can say, oh, let's leave it at 1 and then just give a specific number. Any number you pass, I add 2 to it. It's fine. It's the parameter that makes the difference and not the return type. Okay, I don't know if I gave a definition to it. I think it's just simply using the same method name but different parameters. That's just the simple definition of method overloading.
All right.
So there is there's something called final methods. So if I define, okay, like let's say if I come here and define a method as final, let's use this guy probably final. We cannot override it in either of these places. We can't override it. So that's override public. It's called fly. We cannot override it. In at least in Java, we cannot override it because a final method cannot be anything that you define final cannot be changed. So whatever thing you are saying that this final is here, where is it again? Whatever thing you are saying that this final is here is what it will be in its life cycle in your code. So when you are defining a variable and you say that this particular thing is final, it means it cannot be changed. You cannot say int final number equals oh, okay, no, it has to be in the field. Let's say, for example, here let's do private integer. Private, is it private final? I think it's private final, sorry. Final, yeah, int the number equals 10. You can't come in here and say, oh, now I want this number to now become something else, to become maybe 19. It does not work like that because you say that this is final. It shouldn't be changed, right? So that's the same behavior we have with our final method. When we declare a method final, it means that whatever thing that you have used in defining it, whatever behavior you have assigned to this method on creation is what it should have, it will have in the life cycle. So what does a final, so the use case I would say, or where I've used a final method is, so I have a code that, okay, let's say, for example, if you are throwing an exception in codes, sometimes the message you are returning, this is just a generic example. Sometimes the message you are returning, you want it to not change. You don't want to write this message here, go another place, you are throwing the same exception and you are writing a different message. So you want to just keep using the same message across your code. You can write a method that returns that message and call it across anywhere that you want in your code. Does that make sense?
Yes, it does.
Okay, so there's another method called abstract method. So it's just a method that you define without passing a body to it. So we can say, of course, it has to use the abstract keyword. And what name should we have now? Say jump. Type, then jump. We can have this kind of method. Why is it? I don't know. In a, oh, okay, it has to be in an, yeah, and it has to be in an abstract class. Yes, you cannot just define an abstract method in a normal class. Sorry, that's, so you come here, define your class, say abstract class. I don't know if abstract is a keyword, but just to avoid it. So call it abstract class. Inside it, you can define your method. Make jump not abstract. Okay. Why? You can have the name abstract now. Why am I not able to do that? abstract method cannot have a body. Yeah, it cannot, but then, oh, I was thinking I can actually do this. Interesting. I didn't know I can't put the bracket. Anyways, so this is an abstract method. It doesn't have a body, right? When you are defining your method in some instances in your interface, for example, we'll talk about interface later. You can define a method that has a body in your interface. Maybe it's called a default method. So let's say here defaults. I don't know if I can have a default method here actually. Default, say name or name as this guy, and you can leave it like this. So I can't have it here. Yeah, it has to be in an interface. When we get to classes and objects, we would cover interface. So you can have a method like this. Sometimes some people, they have an implementation for it. They have an implementation for a default class. Then when they go to where they are using it, they can decide to override the implementation that they already have. So what's the benefit of having a default class in interface is because, let me just show you quickly. I know it might be confusing, but don't be confused. So let's say user interface, and we have we'll have this method, say void name, give us a string name, right? Then we have a default, say age. How do I keep forgetting? It's just its age. So this way, we return the age. This is like an implementation. Then usually, this is the confusing part. Usually when you implement an interface, say user interface info, when you have your class that implements implements user interface, it forces you to override this method. That's the behavior of an interface. It forces you to override the method. But you will see that when we are overriding, we can just override this one and it will be okay. Because here, let me close this, guys. Because here we are saying that this guy is default, so it's not forcing us to override it. So if we want a situation where we want to pick and choose what method to override and which one not to override, that's when we use this guy default. So for example, if we come back here and say void email, for example, if we go here, it throws an error immediately. We'll have to implement the email before it lets us be. And you notice it's not throwing an error now, because this guy, even though we are not overriding it, it's still okay. Immediately we remove this, it starts shouting, implement me. We'll touch on interface when we talk about classes and objects, so don't get yourself confused. You can just go and read up on it a bit, so you have some knowledge about it, so you can ask questions when we are discussing it.
Okay. Sorry to.
Yeah, sure, go ahead.
In that user interface, that class, can you override? So you're in default. It's not forcing you to override this, but if you want to now call that particular default method.
Yeah, you can. You do override. Yes, you do your override, your normal override. So you can come here, do override, and what's the name of that interface? What's the name again? Age. Okay. So do public int age.
Oh, all right.
So it returns it. You've overridden it. Yeah. So, but just that you want a situation. If you are in a situation where you don't want to force this class to override everything, that's when you use a default. It allows you to not override a method. Yeah.
All right. Thank you.
Any questions? So there is this unique behavior that Java, okay, I think it's not just Java, I think Python has that behavior actually. So Java allows us to do something magical. So let's say you don't know the number of items that someone is going to pass. So Java allows us to do this public, let's say, let's do void, print, just to print something, print number, print numbers, right? And we do this. So Java allows us to just use these 3 dots. This means pass as many numbers as you can, and I'll print it out for you. It converts it under the hood to a list, right? You see here, it's taking the behavior of list. I think we've talked about arrays a bit. We'll still touch on it when we get to collections and the collection APIs, right? Why is it complaining? No, we don't want to do that. So if we now call this guy, let's do our main method here. Let's make this guy static, public static. And then we say print number. We can pass as many numbers, just comma separated, as we want. It will take it. And when we print, it just runs and prints all these numbers for us. See? So if we add like so this thing here, so it's add some space to it. Okay. So, and then we can do print ln, so it gives it in different lines. Is there any other question? Is there any questions on this?
No question.
Okay. This is actually what I wanted to cover. Let me see if there's any other thing on my notes that I didn't mention. Is there anything? We've talked about recursive methods. Did anyone raise their hand? Okay, Lukman, please go ahead.
Yes, good evening.
Yeah, good
I
evening.
have a question.
Sure, go ahead.
What is the difference between extend and implement?
Okay, so extend is what we call inheritance. Implement is also that, but in Java, unlike Python, I know Python does that. Unlike Python, you can't inherit more than one class, right? So they now used the interface implementation to sort of make that allowance for you to be able to inherit more than one class. So if we have 3 interfaces, our class can actually inherit it using that implement. But we cannot do that. We have an animal this thing here. So let's say this guy that is inheriting animal cannot also do cat. So it's just an avenue for Java is made for us to be able to inherit multiple classes. That is just the difference. So if we come here, if we create another just let's say test user interface, we're not doing anything to it, so we can come here, just give this thing test user, it takes it. So if there are things that is defined here, it will also force you to implement it. That's just the basic difference.
All right, thank you.
Okay, any other questions, please? Okay, so there's yeah, good. There's something called generic method. Can anyone hear me now?
Yes, yes.
Yeah, sorry, they took the lights, so and they disconnected the Wi-Fi. I had to connect my phone.
Okay.
Yeah, so there's another thing called generic methods. I don't know if I should teach that now. I don't know. I really don't. Okay, so generic method generally is when you define your method to take any type of will I say any type of data type, right? So you can define your method in such a way that if you pass this object, let's say user object, let me just give an example. These things would use it when we start talking about classes and objects. So if we can have a method, say, let's do it here. We can have a method, say, like this is how you define a generic method. So public, let's do static. You now pass this guy, use the big capital T here, and then give, okay, it's, yeah. So this is whatever type you give it, it returns it, or not type, whatever type of, whatever type of object you give it, it returns it. So if this array now is not, as you can see now, this array is not integer, is not string, is not anything. Whatever thing you pass into this array, it will take it. If you pass an array of string, it will take it. If you pass an array of numbers, integers, it takes it. This is how you define a generic method. So any method that can take any form of object, that's a generic method. But don't stress yourself so much about it. Later, when we start talking about classes and objects, we would look into that. Okay, I think any other questions? Any other questions?
No, not from my own end.
Okay. Kosi, I saw Christopher too. Was he? Oh, he has dropped off. Even Kosi dropped off. Oh, interesting. So this is the end of today's class. I don't know if there is any questions you can always ask in the group. You can always also ask me, and I'll be happy to attend to it.
Okay. That stuff, that link you sent, they're requiring for someone to register use